In this video, we're going to talk about trig functions. So, in our previous video, we have been talking about functions, support functions. So, if you have not watched my functions videos, I'll encourage you to go and watch my function videos. So, in this particular video, we're just going to talk about trig functions and the basics of trig functions, right? So, the extent of this section or this video is to remind you of some of the more important topics from trig classes, right? So one of the most important but not the first of this topic will be how to use the unit circle. So we will leave the most important topics to our next videos, right? So first, let's start with the 6 trig functions and how they relate to each other. So we'll first have the cos of x and we will have the sine of x. So now let's try to know the difference between this and how they relate to each other. So under the cos of x, we have tan of x being equal to the sine of x over the cos of x, right? And we also have the sec of x equal to 1 on cos of x. Also, under the sine of x, we have the cot of x equal to the cos of x on sine x, which is also equal to 1 over tan of x. You can see that. Now we get into more of that, so just be patient of that. Now we also have the cosec of, so let me just write this in the form of, because it's a long word, so not long as long, but we have CSC, right, of x equal to the inverse of sine of x, right? So we have this now. So this is how they relate, the cos of x and the sine of x relate. Now let's also record as well that all the trig function can be defined in terms of a right triangle, right? So I have my right triangle here, right? So we know that this is our angle of 90, and we know that we have our theta right here. Then so therefore here will be our opposite, and this side will be our adjacent, and we will have our hypotenuse right here, right? So having this one, so from this right triangle here, we get the following definition of the 6 trig function, where we are going to get the cos theta be equal to the adjacent. So I'll represent this as A, and this as H, and this as B, right? So the cos theta will be equal to A on the hypotenuse, which is H. Then we'll have the tan theta equal to the opposite. The opposite is B. Then we have our adjacent be equal to A, right? Then we have our sec theta being equal to hypotenuse, which is H, then over adjacent, which is A, right? Then we also have sine theta equal to the opposite, which is B, then our hypotenuse, which is H. We have the cot theta, which is equal to adjacent, which is A, then opposite, which is B. Then we have our cosec, which is CSC theta, which is hypotenuse, which is H, then our opposite, which is B right here. So remembering both the relationship between all the 6 of the trig functions and their right triangle definition will be useful in this video and in our subsequent videos that we are going to do, right? So next, we need to touch on radians, because this most of the classes or most of the class instructors tend to concentrate doing everything in terms of degree, probably because it is easier to visualize, right? Now the same is true in many science classes. However, in my video calculus, we are going to focus or do everything in radians. So I have a table here where we are going to look at the degree as it correlates in radians. So we have, first of all, let's look at 0 degree. So 0 degree in radians is going to be 0 radian, right? 30 degree in radian is going to be pi on 6 radian. Then 45 degree in radian is going to be pi on 4 radian. 60 will be pi on 3, sorry. So this one will be pi on 3 radian. 90 pi on 2, 180 pi, 270, 3 pi on 2, then 360, 2 pi, right? So we knowing know this table, we may not see the specific angles all that much when we get into the calculus portion, like where we are gonna know. So you just have to know some of them, if not everything, like know some of them is very, very important. Now let's take note at one of the most overlooked ideas from a trig class or trig function. Now the unit circle is one of the more useful tools to come out of a trig class. Now unfortunately, most people don't learn it as well as they should in their trig classes. So let's look at the unit circle right here. So right here is the unit circle with just the first quadrant filled in with the standard angles, right? Now, the way the unit circle works is to draw a line from the center of the circle outward corresponding to a given angle. Then look at the coordinate of the point where the line and the circle intersect. So the first coordinate, that is the x-axis. So let me use this one right here. So the x-axis, so this is our x-axis right here, right, is the cosine of the angle, and the second coordinate, which is the y-coordinate, is the sine of the angle. So we put some of the standard angles along with the coordinate of the intersection on the unit circle, which what we have here. So from the unit circle, so let's look at something right here. Okay, let me clean this one from here. All right. Okay. Okay. So from the unit circle, we can see that cos of pi on 6 is equal to root 3 on 2, and sine of pi on 6 is equal to half, as we can see right there. Okay. Also, remember that the signs of angles works, right? So the positive and the negative works very well in trig functions. So if you rotate a counterclockwise direction, the angle is positive, and if you rotate it in a clockwise direction, the angle is negative. Okay, so recall as well that one complete revolution, which is the 360 degree, that's one revolution is 2 pi, right? So the positive x-axis can correspond either angle of 0 to 2 pi, or pi 4, or 6 pi, or negative 2 pi, or negative 4 pi, and etc. and etc. It goes on and on and on, depending on the direction of the rotation. So likewise, the angle, which is the pi on 6. So let's say the pi on 6. Now, to pick an angle completely at random can also be any of the following angles, right? So we have pi on 6 plus 2 pi should be equal to 13 pi on 6. So you start at pi on 6, then rotate once around the counterclockwise. So this is what we did. So we took the pi on 6, then we rotate once around the counterclockwise, right? So let's pi on 6 plus 4 pi is equal to 25 pi on 6. Starting at pi on 6, then rotate around twice counterclockwise. So if you understand it very well here, so let's look at another one here. So what do we do here? So let's take pi on 6 minus 2 pi. What do we mean by this? So when we do this, we should get negative 11 pi on 6. Now, what we did here is that we started at pi on 6, then rotate once around clockwise, not counterclockwise. That's what we did here. So when you are rotating counterclockwise, we add 2 pi, which is one revolution. Then when we are rotating clockwise, we minus the 2 pi from whatever radians that we have. That's what we do in clockwise direction. So let's look at another one. We have pi on 6 minus 4 pi, which when you do it, you get negative 23. Okay, so negative 23 pi on 6, right? So what did we do here? So we started from pi on 6, then we rotate around twice clockwise, right? So in fact, pi on 6 can be any of the following, right? So which is pi on 6 plus 2 pi n, where we know n should be equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, which goes on. Now, in this case, n is the number of complete revolution you make around the unit circle, starting at pi on 6. Now, positive values of n correspond to the counterclockwise. So positive values, so we know that the positive values of n correspond to the counterclockwise. As we said earlier on, then the negative values of n correspond to the clockwise direction, right? So why do we only put in the first quadrant? The answer is very simple. Now, if you know the first quadrant, then you can get all the other quadrants from the first with a small application of geometry, right? So now let's see how this is done in the following set of examples, right? So let's say we have an example of so example A, we have sine of 2 pi on 3 and sine of negative 2 pi on 3, right? So let's see how this one works. So the first evaluation in this part uses the angle of 2 pi on 3. 2 pi on 3. So that is not our unit circle above. However, we can note that the 2 pi on 3 is equal to 2 pi on 3 is equal to pi minus pi on 3. So the 2 pi on 3 is found by rotating up pi on 3 from the negative x-axis. I know you don't get it. This means that the line for 2 pi on 3 will be a mirror image of the line for pi on 3, only in the second quadrant. So the coordinate for the 2 pi on 3 will be coordinate for pi on 3, except s coordinate will be negative. So likewise for the negative 2 pi on 3, we can note that the negative 2 pi on 3 is equal to negative pi plus pi on 3. So this angle can be found by just rotating down because this is negative, right? Pi on 3 from the negative x-axis, which means that the line for the negative 2 pi on 3 will be a mirror image of the line pi on 3, only in the third quadrant, and the coordinate will be the same as the coordinate for pi on 3, except both will be negative, right? So when we do that, so let's look at something right here. So let's look at something. Let's draw a freehand circle right here. Let's draw a unit circle. We have this and we have that. So this are x-axis and these are y-axis, right? So we have the coordinates of -1, 0. We have a coordinate of 1, 0. Then we have a coordinate of 0, -1. Then a coordinate of 0, 1, right? Where we know that we have pi on 2, and we have 0,2 pi, then we have pi, right? Then here we are going to have 3 pi on 2, right? So what we are going to do here is just do something right here. Let's look at this line from here. So this is our first quadrant. This is our first quadrant right here. So here we have pi on 3, pi on 4, then pi on 6, right? Then we have in our second quadrant we have 2 pi on 3. Then in our fourth quadrant we will have -2 pi on 3, right? So from the unit circle we can see that the sine of 2 pi on 3 is equal to √3 on 2, right? √3 on 2. Then the sine of -2 pi on 3 is equal to -√3 on 2. So how do we do that? So let's see, we have the coordinate to be 1, 2, √3 on 2, right? Then right here we have the coordinate to be -2 √3 on 2. Then under this one we have the coordinate to be -0.5, -√3 on 2, right? And what is the sign right here? The sign is the y-axis, So and under this one we have -√3 on 2, and under this we have √3 on 2, +√3 on 2. We just take the coordinate of the y part, the y coordinate. That's what we take for the sign, because we are just dealing with sine. We are just dealing with sine. We are not dealing with cos. So if we're dealing with cos, like let's say here was supposed to be maybe cos, and here was supposed to be cos, then we will take half, -half, -half from here, right? Which is very simple something to do. It's very, very simple to do. So this is the end of this video, and I'll see you where we practice more questions on this type of topic. Thank you for watching, and I'll see you in my next video.